is example 3 from the Rational Functions Part 1 lab. We have the following function. We want to find some attributes of it, such as its domain, if it has any holes, vertical asymptotes, or x-intercepts. So what we're going to do is we're going to factor to the numerators and the denominators. So factoring x squared minus 2x minus 15, we have x minus 5 times x plus 3. And for x squared minus 7x plus 10, we have x minus 5 times x minus 2. So our denominator will tell us what our domain is, because if our denominator is 0, that excludes those x values because that function is then undefined at those points. So if our denominator is 0, then x would be 5, and x here would be positive 2. So at these values, this whole function is undefined. So we could write it, our domain, like that, or we could write it of what it does include. So we can have x values from negative infinity to 2, and from 2 to 5, and from 5 to infinity, not including 2 and 5. So if we look at our function, we have 2x minus 5s, which means we can cancel that. Now what this means is that we have a hole here at the value of x is equal to 5. So our hole is at a point where x is 5. The x value is 5. So we need to find the y value of it. So the way we'll do that is we'll take this function without the hole. So if we cancel this hole here, we have x plus 3 and x minus 2 is our new f of x, essentially. And we're going to plug in our 5, which is where our hole is at. So, plugging in our 5, we have 5 plus 3 over 5 minus 2. And 5 plus 3 is 8. And 5 minus 2 is 3. So our y value for our hole is 8 over 3. So now for vertical asymptotes. Vertical asymptotes appear on the denominator where it cannot equal 0. However, because x minus 5 is a whole, the value of x equals 5 is a whole, we only have one at 2. So our vertical asymptote is x equals 2. And for x-intercepts, that's when the top is equal to 0. But since x equals 5 right here is a whole, we only have one x-intercept where x plus 3 is equal to 0. So if x plus 3 is equal to 0, then x is equal to negative 3. So we have a x-intercept at the point negative 3, 0.